Hello students, welcome to the next lecture of Strength of Materials. We are currently studying unit number 1. Let's see this lecture. So, as you know the syllabus we are discussing, we are currently in the simple stress and strain, elastic behavior of body under external actions and Hooke's law. Hooke's law and stress strain curve we studied in the last lecture. So, let's take a review of last lecture so that we can go forward in this lecture. Three things we studied. Firstly, what is ductile material and brittle material, the stress strain curve of ductile material with various points like ultimate load point, breaking point, elastic limit, and stress strain curve for brittle material which was directly a single point of breaking. So we'll move forward using these points in this lecture. So firstly we study today is the types of stresses based on stress strain curve. There are various types of stresses which are related to the stress strain curve and which will be practically seen in our practical at UTM on universal testing machine using tension test on mild steel, torch steel and various other practicals. So the first stress is nominal stress. So how we define the nominal stress is the stresses which are calculated by dividing the respective loads by the original cross section area are called as nominal stresses. So it is denoted by a formula. Nominal stress is equal to load at breaking point divided by original cross section area. Means whenever we fix a bar in a UTM on both the sides and we apply a tensile load on it, at a particular point the bar breaks and the load at that particular point is called breaking load or load at breaking point. And original cross section area is pi by 4 d square, means if the diameter of the bar is 16 mm, then it is pi by 4 16 square, which gives us the original cross section area. And load you already know that it is measured in Newton or kilonewton. Also from the stress strain curve it is clear that the nominal breaking stress is less than the ultimate stress. Next, as you see the formula, this is a specific formula for nominal stress. Next we'll study actual stress. So the stresses which are calculated by dividing the respective loads by the reduced cross section area at that point are called as actual stresses. So the actual stress is a ratio of, as we define, as load at breaking point divided by reduced cross section area at fracture. In the earlier formula it was numerator was same, that is load at breaking point, but at denominator it was original cross section area and here it is reduced cross section area. So what is the difference between the two? Original cross section area was the actual area of material and reduced cross section area is before breaking or during breaking the diameter of the bar is reduced, so the cross section area will be reduced. Likewise, example, initial diameter of the bar was 16 mm before the test and during the test after the application of load and before breaking the diameter reduced down to 12 mm, means pi by 4 12 square. So this difference is known as reduced cross section area at fracture. Fracture means the point at which the bar will be breaking. So this is the formula for it. And from the stress strain curve it is clear that the nominal breaking stress is considerably higher than ultimate stress. This is a particular stress area at which the region will be more than the ultimate stress. Means this is a particular type of on the curve where the stress will be more than ultimate stress, which will lead to ultimate breaking of the bar. Next, number 3 is yield stress. So how we define yield stress? It is the ratio of yield load to the original cross section area. So given by formula, yield load in the numerator divided by original cross section area. You studied the stress strain curve for ductile material. In that we found 2 points, upper yield point and lower yield point. So this stress is related to that 2 points, means yield load. So it is a nominal stress corresponding to yield load. Next is ultimate stress. Now the word ultimate means maximum. So it is a ratio of maximum load to the original cross section area of material or specimen. Means whatever maximum load we apply on that particular material or bar, and that load divided by original cross section of the bar, area of the bar, gives us the ultimate stress of that particular material. It is a nominal stress corresponding to maximum load. So whatever stress is corresponding to that particular load condition, we call it as nominal stress. Next is working stress or allowable stress. So how we define working stress? It is defined as or a ratio of actual axial load divided by original cross section area. So actual load the bar may be taking divided by original cross section area gives us the working stress or allowable stress. This concept is very important in the regular design of structures. We'll see. It is the maximum allowable stress to which a material is subjected during its entire service period. Means this is the stress. Working means what? Whatever the structure has to resist the stress which will be it carrying throughout its entire life. Means the normal regular working stress means in an industry there will be load of machines and any other parts components, the weight of it. In a residential structure, the weight of the people moving around, the weight of furniture and other items what we use normally in residential structure. So this has to be considered. Another important part of this is for the safety of the structure, it is very essential that working stress should be within the elastic limit of the material. Means we have to understand what the structure will handle the working stress. So accordingly we have to design the structure in such a way that it follows all the safety measures. Next is factor of safety which is related to working stress. So it is a ratio of ultimate stress to the working stress. Now we see that both the terms look almost similar, ultimate stress and working stress, but there is slight difference between the two. Ultimate means maximum, a particular peak point as we see on the curve, a particular point where the load rises suddenly and the bar breaks. And working means normal stress, means normally it can withstand. So this is the difference, minor difference between these two. Also factor of safety is defined by another formula which is yield stress divided by working stress. So whatever amount of yielding that will be occurring, it will be also equal to yield stress upon working stress, which will give us the factor of safety. So in design of residential buildings to resist accidental loads, sufficient reserve strength is required to be ensured, which is carried out by taking suitable factor which is called as factor of safety. So always whenever the structural designer designs a structure, he keeps the factor of safety higher so that on-site conditions due to bad quality or due to human errors, if the quality gets reduced as as per the standards, the structure should not be supposed to failure. So it is designed in such a way that given maximum factor of safety. Also factor of safety is always considered than unity means 1, means factor of safety value should be always be greater than 1. Now next concept is types of strains. Now we define the strain in the earlier two lectures. It is ratio of change in length to the original length. So there are two types of strains. First is linear strain. So it is a strain in the direction of applied force is known as linear or primary or longitudinal strain, which is same as regular strain. So how it is defined? Linear strain is equal to change in linear dimensions upon original linear dimensions, or you can say change in length upon original length. Means take a particular bar of particular length, suppose 1 meter, you apply the tension load on it, and after application of the load it will expand by suppose 0.100 mm. So that change in length upon original length will give us the linear strain. So it is denoted by the formula E is equal to delta L upon L. Delta L means change in length and L means original length. E or epsilon is denoted for linear strain. So next is lateral strain. So lateral strain is a strain in the direction at right angles to the direction of applied force is known as lateral or secondary strain. Means any strain which is applied in the direction at right angle to the particular member, that strain will be called as lateral strain. In the earlier linear strain, we studied about the length, but in lateral strain, anything apart from the length of the member like width, thickness, diameter, and change in that amount is called as lateral strain. We'll see in this formula, lateral strain is given by change in lateral dimension upon original lateral dimensions. Means suppose a bar having a width of 10 mm, and after applying tensile load its width changes to 15 mm. So this changes in width or thickness or diameter is called as lateral strain. So it is denoted by E suffix L, and ratio of delta B to B means if it is the width of the member, small b we will use. If it is diameter or thickness of the member, it is delta T by T, means change in thickness upon original thickness. And third case, if the bar is circular, we'll say change in diameter means delta D upon small d means original diameter. So these are the terms we will be using depending what type of member, circular, rectangular, is given in the question. So these formulas are important while solving the questions. So next important type is Poisson's ratio. So to understand this concept in a much better way, we'll watch this video ahead so that you can get an idea what is exactly Poisson's ratio. So we can explain it further.
Poisson ratio. To understand Poisson's ratio, let's take an example of a rubber strip as shown. When we pull this strip in a longitudinal direction, the strip elongates in a longitudinal direction and contracts in a lateral direction. The strain developed in a longitudinal direction is known as longitudinal strain, and the strain developed in a lateral direction is known as lateral strain. Now, when we take the negative ratio between this lateral strain and the longitudinal strain, we get Poisson's ratio. Poisson's ratio can be represented as Poisson's ratio describes the relative change in the lateral dimensions of an object when the load is applied in longitudinal direction and vice versa. Poisson's ratio for some of the important materials are as shown.
So from the video, you must have got an idea that what exactly Poisson's ratio is. So let's see in the formula terms. When a homogeneous material is loaded with an elastic limit, the ratio of lateral strain to the linear strain is constant and is known as Poisson's ratio. We usually denote Poisson's ratio by mu or 1 upon m. So it is given by the formula Poisson's ratio is equal to lateral strain upon linear strain. So don't confuse with the numerator and denominator as both the words are similar. So it is always change in lateral dimensions upon original dimensions, means lateral strain upon linear strain. Denoted by formula mu is equal to EL upon E. E lateral is denoted by EL and regular linear strain is denoted by E. So let's take quick review of today's lecture. We understood the different types of stresses based on stress strain curve. So you should be able to define those in oral practical exam as well as if asked in the theory exam of university paper. Next, define lateral and linear strains. This could be asked for 2 to 3 marks in the university theory paper. And lastly, what do you mean by Poisson's ratio? This formula is important for solving the problem as well as it can be asked as a theory part in oral as well as in theory paper. So that's it for today's lecture. Take a review of this, and if you have any doubts, ask me personally or message me. Thank you.